تحت. ايوه دي trended normal.
It's a deviation from normal. To interpret this plot,
Not يعني what's the concept?
you look at these zeros.
هذه common في nutritional study by the way.
Really?
I find it a lot. وش والدي attenuated coefficient
إن شاء الله.
ما أنا عارف. الدي attenuated ياخذوها دائما. ما أدري إيش الكونسبت.
هذيك الورقة اللي أرسلتها لي.
هي قرأتها قاعد تقراها.
والله. Very interesting. Did you look at YouTube?
ايوه.
YouTube.
ولا ليش عرفت الدي ترند وهذه الامور وجاوبتك على وش كان. بس المشكله انه نفس الكونسبت حق الموديل لما قرأت الورقه قالوا انه في الاخير they replace it by sensitivity test. They would like to use instead of measurement error model to correct the variation between the tool FAQ and the variation among the participants. They said okay sensitivity analysis would be better.
Yeah.
But I didn't come across sensitivity analysis only in one study historical last year semester. So this is the advance.
ما شاء الله.
We need more because when I read something, especially they talk the mean coefficient correlation.
Yeah.
They ياخذوا the median. That's why I said median. When there is outlier, median coefficient. Then they done the de-attenuative to bring up to the normal. I didn't understand.
Well, it's good. Yeah, keep reading. Yeah.
Thank you for
Well done.
QQ.
Yep.
So, and just an applicant, proposal can be valid.
الجديد بتاع البوين
Point
5
5,000
Slide.
European.
والله هم بيحاولوا يضغطوا على الشركات الأدوية فعلا. أعتقد إنه if you look at the literature خاصة literature بتاعت clinical trials, most of the study published in clinical trials always you see the result in favor of the drug itself.
صح.
صح؟
صح.
يعني دائما لما يكون ما في لقوا ما في effectiveness they will not publish it or خلاص يحطوها في drawer ولا ينسوا الموضوع.
FDA.
Exactly, a big violation. Yes, there is a need actually for some restrictions, لكن ما أدري إذا كان هذه الطريقة هي الأصلح. في طرق أخرى ممكن you can adjust. قلنا نحن بموضوع adjustment بتاع البي value نفسه you can adjust it.
الباور.
لا في طريقة ثانية you can adjust the B value by dividing of the number of tests you are doing or number of let's say إنك عندك 3 drugs.
طيب.
كويس. The 3 drugs they say you're going to compare drug A versus drug B and drug A versus drug C, right? And then drug B versus drug C.
Okay.
So you are doing here 3 tests. So good luck. You can adjust the B value. Well, it's significant. You can adjust the alpha itself by multiplying the alpha times the number of tests you are doing. So likely you're going to multiply, the like 2 times 3, which is 6. So you'll divide it by 6 instead. So 0.05 divided by 6. You're going to adjust the new cutoff by saying no. I'm going to just use 0.005. I think that will, it will be appropriate for whatever that group comparison you are doing. If you are doing 3, then you need to have a different cutoff. If you have 4 groups, then a different cutoff from the 3 groups. If you have 2 groups, this is a different cutoff from the 3, a different cutoff from the 4. So now it's not just a fixed لهم كلهم.
Still we have.
So you need to make the adjusted alpha. You have to adjust alpha. Depends on the number of tests you are doing.
But what about increasing the power of the study? That will lead to increased sample size.
But again, this is a clinical trial. You should calculate exactly the sample size. It's not just like a cross section. You can include anybody. You know, you need to have a restrict sample. Yeah. Yeah, I think it's good. But the way they fix it, just say use 0.005.
It's the same mistake of using one.
It's not gonna convince me as a statistician, or they can say now you need to adjust the alpha depending on the number of testing you are doing or the number of treatment you are giving to the patients. You know? Yeah.
Good to know this.
عندي publication ما أدري كان ما أدري هنا موجود. السنة اللي فاتت تبعت السيكل سيل. Yeah, I think I can open it in Blackboard. Look at this. I think this is addressing the quality of life. I'm doing independent sample t-test. If you remember, these are the quality of life measures, right? So I put them all together. A quality of life measuring physical function from 0 to 100. 0, poor physical function, 100, best physical function. Same thing, rule limitation due to physical function. 0, poor, 100, best, right? Same thing for this. So I have done an independent sample t-test to compare physical function by female, male, right? This is independent sample t-test, isn't it? And also by age, all the age, yes or no. By university, yes or no. All of these are comparison of independent sample t-test. So I'm going to do here multiple testing. لأنه كلها independent sample t-test on one variable, which is physical function. So the p-value هنا شوفها هذه كم كانت 0.019, right? Yeah. It is significant, correct? Yes. But I need to adjust my alpha. Why I'm doing this? I'm doing like 15 different comparisons.
Divided by 15.
So I have to divide alpha by 15. As you can see, the calculation done here. Look at this. Alpha divided by n. N is the number of testing that I'm doing in this for every variables. So I have to adjust for alpha. Say alpha divided by n. N what? N the number of tests I'm doing. So alpha, what is alpha? This is the actual alpha, 0.05. 0.05 divided by 15. This is give us new alpha, which is 0.003. Now, any value, any b value that lower than this, it considered significant. Only see how the restrictions. So now, any value above this, it is not significant.
Distributing this equally among all tests, it's not reflect the impact of each one of them. Clinically wise.
Yes.
Clinic.
Yes.
And it may have impact of, for example, smoking more than age
Yes.
and lung cancer. So if I distribute significant equally between age, not age, male or female, against lung cancer, it will not be fulfilled, logic-wise or clinically wise. Statistically acceptable,
Yes.
but clinically.
Even clinically, sometimes, even if we're testing differences, right? So likely, look at this.
Not sure.
Are there plots that can increase this? Yes. You should,
Yeah.
Look at these. Look at these too. This is the mean physical function among female. This is the mean physical function among male. It's 57 compared to 52. If I use alpha 0.05, it says clinically this is significant difference. Is that right? Is that clinically difference?
No.
Only 5 score?
No.
But if I just my b value or my alpha, now this becomes not a significant difference. So the 5 score is not enough to make that difference. You see the point? So this is why we need to adjust. We need to be more strict on our b value. So look at the next one. Look at this. Is this significant?
Only this. With,
It's not. It's not significant. Is it significant?
maybe it's significant with point.
This is more than 0.03, 0.003, right? So it is not significant, and this is why you look at the difference here. This is 53, this is 59, it's not much difference. Right. So now, again, look at this. Is it significant?
Yes.
Yes.
Yes, 53 is 60. Now you can say this is clinically different, maybe. See that? So all of these are just to be more strict now, looking at why I'm doing this now, because there's significant difference. So it should be, this is also, it makes sense, right? Because it's 0.003. So it is significant. This is how we adjust your sample size. So the paper that it comes for the clinical trial, if they try to convince people using this approach, it's better than saying, no, you have to just fix your alpha to be 0.005, right? So it depends on the number of tests I'm doing. If I'm doing more, I have 3-4 treatment, then I have to divide by the number of treatment. If I have 4 treatment, then I have to divide 0.05 divided by what? Like this. So it would be 0.05 divided by 4. So this is my new alpha. Yes, right? Yes, what they mentioning, Muhammad saying that why not, was I, yeah,
غالبا في
so that,
الافكاسي كترايل الادويه غالبا يكون 1 او 2 تيست ما هي كثير ما اتفق معك.
I have seen some clinical trial using 4, 3, maybe,
Victoria.
yeah.
Victoria.
So there is some exist, but yes, it's a few of them maybe, they're comparing multiple